So in this lesson, we're going to look at how to represent complex numbers on the complex plane. We're going to look at a diagram called an Argand diagram. Just to note, the word Argand has got a capital A. That's because it's named after the mathematician who developed this type of diagram. So this is an Argand diagram here. As you can see, it's got two axes. We've got the horizontal axis, which has got the real numbers on, positive and negative. And then we've got the imaginary axis going vertically, and that's got imaginary numbers on. So if we wanted to plot a number on an Argand diagram, it's a bit like coordinates. You just plot it in the correct place on the grid. So for example, if we had the number z equals 3 plus 2i, we would go 3 across on the real axis and then 2 up on the imaginary axis. So 3 plus 2i would be plotted there, just with a cross. Similarly, if we wanted to plot the number z equals minus 4 minus I, we'd go across minus 4 in the real direction, and then we'd go down 1 to minus I in the imaginary direction. So minus 4 minus I is plotted there. So here are 5 complex numbers, z1 to z5. I'd just like you to pause this for a moment and see if you can plot those in the right place on a sketch of an Argand diagram. Okay, so hopefully you've had a chance to pause those and plot the points in the right place. So I'll go through the answers. So Z1 minus 2 plus I should be there. Z2 4 minus 3I should be plotted over there. Now Z3 is purely imaginary, it's just 2I, there's no real part. So that is on the imaginary axis itself at 2I. And similarly, Z4 is a purely real number, there's no imaginary part there, so minus 5 is just going to go on the real axis at minus 5. Finally, Z5 equals minus 2 minus I, that's going to go there. So there are your 5 points on the diagram. Now you may notice Z5 and Z1 are complex conjugates of each other because they've got the same real part, but the imaginary parts have got opposite signs. And the way that that's shown on the Argand diagram is that it's essentially reflection in the real axis. Okay, and then just to complete today's lesson, if you can just do the questions on page 12, exercise 1C, please.